Hey there, everyone. How's it going? Welcome to the next set of lectures regarding your hormones and exercise. So, some of the next topics that we'll discuss, in particular, this next section, might not completely directly cover every part of exercise and your hormones and how they interact. But as exercise can relate to these hormones of topic, we'll definitely explore that concept. So what I'm trying to say is this first one's going to be a little bit of physiology based with some tie into exercise. But when we talk about hormones specifically as we move forward, those will have a heavier tie into exercise, so we'll focus on those. Okay, so we'll start with the hypothalamus and pituitary. And what we find with these two structures is they kind of work hand in hand together to help regulate and control most all hormones in the body. So our hypothalamus really isn't just involved in our hormonal system, but it also helps regulate a lot of our other body functions as well. It's kind of like this relay center or control center for a lot of different feedback loops in our body. And because of that, it's prime key center sort of hub for being able to help regulate our hormone system. So it will help, promote or inhibit different release of hormones, and it does that with the help of the pituitary gland, which is our master gland. So what I mean by that is it truly sends out signals to release or inhibit hormones throughout our body. It's a very small gland. We'll get a picture of this in a moment, located just below the brain, and its hormones influence most physiological functions throughout our body. And one of the ways that these two glands or centers are connected is through the hypophyseal portal system. And what that is it's like a mesh, it's like a net almost of capillary or a blood system that enmeshes or encircles the two glands and allows, or the two aspects of the pituitary. So there's an anterior or front and posterior back part of the pituitary gland. And it essentially allows communication and very close and direct communication between the two. So, and that's kind of the key point to this hypophyseal portal system, is that the two glands are able to directly speak to each other because they have this not totally isolated, but confined blood system between the two. Okay. So here's a photo, or an illustration, sorry, of the hypothalamus and the pituitary. Okay, and what this schematic shows, or this diagram over here, indicates that. So here's our higher brain functions. Here's the pineal gland, which is related more to sensing light, helps with our circadian rhythm. But we got our hypothalamus here, the pituitary here. So you can see it sits right at the bottom deep center of our brain. And when we take a look closer at the schematic, we can see that we have blood flow heading into the hypophyseal system here, and you can see how tightly enmeshed we have of a blood system for the pituitary in particular. And so we can have very direct communication between the two anterior and posterior glands, but also farther down the system, when they release hormones, it can get released into our blood system to signal things farther down the way. You can see in particular, when we're talking about the communication aspect of things, our hypothalamus has a nerve or a nervous connection to our posterior pituitary in particular, to cause a release of hormones into the hypophyseal system. So it is a combination between both neuronal and blood-based communication. Uh, One aspect that I like about this diagram for you is it does help kind of categorize or separate what hormones are released by the anterior pituitary, and it gives you a little pictorial illustration of how each of these hormones might play or interact or have an effect farther down stream in our bodies. And here we have the posterior and the hormones involved in there. We're going to chat in a couple of slides about those a bit more specifically, okay? Good, but I think just to loop back in, and I know I've already said it, but just to kind of tie in this point again a little bit clearer, the hypothalamus does both spur on the releasing of or inhibiting, so another word for that is stopping, of hormonal release. And it does that by its communication to the anterior pituitary in particular. But again, if we dive into a little bit more specific here, we'll see the posterior pituitary releases oxytocin, which you might have heard of before. So it's a hormone that's closely related or really, really important for things around childbirth, but also I think more for us day to day. It has an important influence in our social connections and sex kind of related relationship building. That's its primary function, is more of a social hormone. I think some of you might have heard of it referred to as like the love hormone, because it's heavily involved in that. So a little less exercise based, I guess, but it does get increased through exercise. Vasopressin, which can also be called antidiuretic hormone, this isn't how it's actually written. I just capitalized the letters that correspond with the common nomenclature or shorthand, just so you can see how that is. So ADH, believe I previously mentioned in one of the other lectures that this is primarily used, or the primary cause of becoming dehydrated and therefore hung over when you are drinking alcohol. So antidiuretic hormone, when it is released, causes an increased reuptake of water. So when we're exercising, it's a little bit of complicated balance. And it's not fully understood, this mechanism, but when we're exercising, we have a very high elevated amount of ADH. And if we think about that for a moment, it kind of makes sense in the sense that we're exercising, we're sweating a lot, so we'll want to reuptake a lot of fluid as best as we can to keep it in our bodies so we don't become dehydrated, even though we have a fairly high fluid loss during that time. And so this happens at the kidneys. I should make that a bit clearer too. So our kidneys will reabsorb water as they're filtering out different fluids and stuff. Okay, so antidiuretic. A diuretic means to lose fluid, I guess, would be one way to think of it. So so that increases during exercise, and that's from our posterior, and you can say middle, but if you just say posterior, that's fine for now. Great, so we can move forward onto the anterior hypothalamic region, and what happens at the anterior pituitary. So what happens is the hypothalamus will signal to the anterior pituitary to it gives this corticotropic releasing hormone, or CRH. But what that in turn stimulates from the anterior pituitary is adrenocorticotropic hormone, or ACTH. So again, I just kind of capitalized the letters there that correspond to its more common shorthand. And when the anterior pituitary releases this, what happens is it goes to our adrenal cortexes, and we get a release of cortisol. In particular, this is an important one to kind of focus on. So with this release of cortisol, You might have come across this if we've ever heard of people talking about stress. And so this gets released for the stress of exercise as well. And what it does is, again, increases all our systems that are related to our fight or flight system. Now, the issue with this, and this is part of the HPA, or the hypothalamic pituitary adrenal system, is in modern life, a lot of times this system gets activated even when we aren't in immediate danger, right? So the idea behind fight or flight is it helps protect us from immediate danger. This is a biological response that animals get in the wild when all of a sudden they start getting hunted by, if they're prey type animals, right? So the idea is it stimulates all these systems that help us with fight or flight. So increased heart rate, our vascular response, eyes dilate, or pupils dilate so we can take in more light. But it also frees up a lot of energy. And so in our modern day, when we get this fight or flight or stress response, just from, say, like a cognitive or a mental stress response, we have all this free energy flowing around our body, which then doesn't get used, and that can lead to cardiovascular diseases. So we can get plaques, for example, building up on the inside of our arteries, and causing blockages or emboli and stuff like that. So again, cortisol is a big thing. Yes, we need it for day-to-day life. It helps us in our sleep, our wake sleep cycles, right? Our circadian rhythm. But many of us nowadays in our modern life, we can be proactive and try to minimize the amount of cortisol that affects our bodies. And the last point about cortisol, because it's so important, is high cortisol levels, especially for a prolonged period of time, suppresses immune function. So our immune system with high levels of cortisol will become suppressed. So a lot of the time when people are selling products or trying to promote their health systems, when it's related to relaxation, and they tend to heavily promote how it improves or makes our immune functions more robust. And what that is actually through decreasing cortisol levels will increase your immune system. So to that end, my take-home note for you to be able to work in at home is anytime you can work in 2 minutes, 5 minutes of mindfulness. There's lots of information and resources out there if you search for it on the web. But anytime you can work in just a little bit of stress relief throughout your day, or even just mindfulness, even if you're not stressed, great practice to undertake. It helps reduce cortisol levels when we're just in our day-to-day lives and improve your immune function. So there you go. Okay. As far as exercise, we need this, right? We start exercising is good. That free energy, that heightened awareness, alertness, etc., our preparedness physiologically for exercise that cortisol brings is great. Without it, exercise wouldn't really work as well as it does. So again, in times of exercise, this is a great hormone to have available to us. Okay, continuing forward, the anterior hypothalamic region again signals the anterior pituitary through gonadotropin releasing hormone to release LH, so luteinizing hormone, FSH, follicle stimulating hormone, and testosterone. Okay, and so these two in particular are important for women. In particular with the reproductive or like menstrual cycle, and testosterone is obviously important for men and women, in particular men when it comes to sexual reproductive health, but both for just generally keeping our anabolic systems for muscular regrowth. It's important. Growth hormone releasing hormone, believe it or not, spurs on the release of growth hormone, and we'll actually, that's going to be one of the next lectures that we really focus on this hormone specifically, so I won't say much about it now. And thyrotropin releasing hormone, again, this is coming from the hypothalamus, releases thyroid stimulating hormone, which is really, really crucial for things, everything from growth, but metabolism, heart rate, and body temperature in response to exercise. So we start exercising, we get a little thyroid stimulating hormone, helps get our heart rate up, increases our body temperature if we're getting too cold, things of that nature. Okay, great. And so that is the hypothalamus and the pituitary.